byte 1, byte 2, byte 3 and byte 4. Among these 4 bytes, we have this for host. Okay, that means there is a change in the last block only. Last block means last byte, and last byte means last 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. In the same way here also 1, 2, 3, 4, 5, 6, 7, 8. Fine. Now we have to divide this into 2 subnetworks. So what we'll do, we'll write 0 here and 1 here. We are dealing with binary. See, this will also be converted into binary, but I'm not converting then because this will remain same. So this is 0 and this is 1. That means what we have to do, we have to fix the MSB. The MSB will be fixed. Okay. Now this will remain fixed. We can modify only the remaining 7 bits. That means for subnetwork 1 and subnetwork 2, this is fixed. For subnetwork 1, this is fixed. So we are left with 7 bits. So हम क्या करेंगे? We'll start with 0. We'll fill all zeros. Okay. This is the first IP address of subnetwork 1. Then this 0 is fixed. The second IP address of this subnetwork 1 is 0, 0, 0, 0, 0, 0, 1. Next is 0, 0, 0, 0, 0, 1, 0. Okay, and up to this 0 is fixed and this will be 1, 1, 1, 1, 1. तो हम क्या कर रहे हैं? हम सिर्फ यहाँ पर 0 और 1 के टोटल कॉम्बिनेशंस लिख रहे हैं. लास्ट कॉम्बिनेशन क्या होगा? When all the bits are 1 and this is fixed. We are not changing this. Clear? In the same way, subnetwork 2, 1 is fixed. We'll start with 0, 0, 0, 0, 0 and then we'll modify. Last will be 1, 1, 1, 1, 1, 1, 1 and this 1 is fixed. So this is what? This is the range of IP addresses that are available in subnetwork 1 and subnetwork 2. That means range of subnet 1, subnetwork, or you can say subnet. Subnet 1. Range of subnet 1 is 200.10.20.0. This is 0 to 200.10.20. What is this? 0, 7 times 1. 0, 7 times 1 is 127. Okay. In the same way, range of subnet 2 is 200.10.20.1 and 7 times 0. This is 128. You can convert. This is in binary. Convert binary to decimal. 1 7 times 0 is 128. So 128 to 200.10.20. 8 times 1 is 255. Clear? We have divided the entire class C network into 2 subnetworks. One subnet 1 that ranges from 0 to 127. Another one that is subnet 2 that ranges from 128 to 255. Now, if we talk about the subnet ID of S1, subnet 1, that is equal subnet ID, or you can say network ID of subnet 1. That will be equivalent to the first IP address. That means 200.10.20.0. Okay, and the direct broadcast address, or you can say the IP address that will be used in this subnetwork 1 for broadcasting would be the last IP address. That means 200.10.20.127. Sorry. Clear? Now in subnet 2, the subnet ID is first IP address, that means this one, 200.10.20.128, and broadcast address for this subnet 2 is last, that means 200.10.20.255. Clear? Now one more thing, let's find out the total number of hosts that are available in subnet 1 and the total number of hosts that are available in subnet 2. The total number of hosts is equals to, what is the range? 0 to 127. That is, how many we have? 128. But out of these 128, 2 are reserved. These 2 are reserved. So total usable IP addresses are 128 minus 2, that means 126. In the same way, the total number of hosts in subnet 2 is equals to, again, 128 to 255, 128. So 128 minus 2, 126. That means total number of IP addresses is equals to 126 plus 126. That means how many? 252. Clear? This is for subnet 1, this is for subnet 2. But earlier when we calculated the total number of IP addresses in this entire network, that was 254. But when we perform subnetting in this network, then the total number of usable IP addresses decreased by 2. Why? Because 2 IP addresses are assigned, or 2 IP addresses per subnetwork are reserved as your subnet ID, or you can say the network ID of subnet 1 or subnet 2, and one is broadcast address. So total usable IP addresses in this network after performing subnetting is 252, and before subnetting it was 254. I hope you can figure out the difference. Okay? Clear? Now let's move to the questions. Let's move to some numericals related to IP addressing and subnetting.